Okay, so today we're going to be talking about molecular shapes. So the shape of a molecule is determined by the number of things that are attached to your central atom. So the things are either like electron groups of like a lone pair, or it could also be another atom. Okay, these are negatively charged. These things have electrons, they're either electrons themselves or they're um, other atoms that contain electrons. So they're going to repel each other. So they're going to get as far apart as possible. Okay, so these are the things that I'm going to use in this video. Your central atom is going to be a red circle. The bonded atom is going to be a smaller black circle, and a lone pair is going to be represented by like a parachute holding 2 electrons. Okay, so electron geometry and molecular shape remind me of your location in Stonington. So electron geometry, so we are all Stonington residents in this room, okay? So that's like your electron geometry. So anything that like has 4 things around it has an electron geometry of tetrahedral. Okay. Now, you could live in regular Stonington, which is like this area. So your electron geometry is tetrahedral and your molecular shape is tetrahedral as well. Okay. Or you can live in the town of Stonington, but like me, live in Pawcatuck. Okay. So your molecular shape is just basically a more specific description of what your electron geometry is, depending on how many lone pairs you have. Okay. So if you have 1 or 2 electron groups around your central atom, your electron geometry is going to be linear because the furthest apart 2 things can be is 180 degrees on a straight line. Okay. And I just want to make this point here that the number of bonds between 2 atoms, like let's say this was a double bond, matters not at all. Okay, does not matter at all. The number of lone pairs on the outer atoms does not matter at all. The only thing we're concerned about is our central atom, okay, and the number of lone pairs or bonded atoms. So here's a lone pair. Here's a bonded atom attached to our central atom. So the central atom is like our player. Okay, it's our player, and like these guys are our NPCs. Okay, so if you have 3 things around your central atom, you have a trigonal planar geometry. Okay, so they are 120 degrees apart and they can lay flat on a plane. Okay, so really the only kind of you only really see this when you have boron. Here is your central atom, and boron is the only element that is satisfied by having 6 electrons around it. I'll explain that a bit later. And so these will spread out 3 ways. Okay. So it's 3 groups, 3 things around your atom. Okay. Now, if all 3 are all 3 are bonded atoms, and your molecular shape, like the ones with boron, is going to be trigonoplanar as well. Okay. So if, again, I just said this on the previous slide, your electron geometry is trigonoplanar and your molecular shape is also trigonoplanar. Okay, this to me reminded me of Rudolph the Red-Nosed Reindeer. That's why I put it here. So if all of those things besides 1, so if 2 things are atoms and 1 is a lone pair, it's taking up space, but you can't see it because you can't see electrons. But atoms you can kind of visualize. Well, your electron geometry is still trigonoplanar, but your molecular shape is bent because you're seeing it go up and down. It's kind of like a V shape. Okay. Again, electron geometry, trigonoplanar, molecular shape, bent. If you have 3 things around your central atom and 1 of them is a lone pair. If two things are lone pairs, and only one is another bonded atom, then it's going to be linear. Okay. So your electron geometry is still trigonal planar, but your molecular shape is linear because you're just going to see this. And these reminded me of elephant ears, so that's why I put this little cute little elephant over here. Okay, now here comes the tricky one. It's not that bad. Okay, if you have four things around your central atom, you have a tetrahedral, which in 3D looks like a tripod. Okay, so if you have four things, I don't care what those four things are, your electron geometry is tetrahedral. Tetra meaning four. If all four of those things are atoms, your electron geometry and your molecular shape are tetrahedral. Okay, so 1, 2, 3, 4 atoms. And they're going to be 109.5 degrees apart from each other. No, you don't need to memorize that. If one of those things is a lone pair, okay, so if you have four things, your electron geometry is tetrahedral, but your molecular shape is pyramidal or trigonal pyramidal. And you can see it creates this, I have to go in the background, pyramid shape, okay, around your central atom. If two things are lone pairs, then it's going to be, the space is taken up here and here by lone pairs, and we're going to have a bent shape again that came up earlier. Okay, so your electron geometry is tetrahedral and your molecular shape is bent. If three things are around it, but only one of them is another atom, then it's going to be linear. It's just going to be a straight line. But your electron geometry is still tetrahedral. Now this chart kind of organizes all of these thoughts. So if around your central atom you have two electron groups, okay, your electron geometry is going to be linear. Now, if both of those things are other atoms, your molecular shape is also going to be linear. And if one of them is a lone pair, your molecular shape will also be linear. If you've got three things around your central atom, okay, three electron groups around your central atom, your electron geometry is going to be trigonal planar, so no lone pairs, okay? So your electron geometry is trigonal planar, your molecular shape also trigonal planar. If you've got one lone pair, your electron geometry is going to be trigonal planar, but your molecular shape will be bent. And finally, if you have three things around your central atom, your electron geometry is trigonal planar, but your molecular shape is linear if you have two lone pairs and one atom. If you have four things around your central atom, your electron geometry is going to be tetrahedral. So it's four things, and if all four things are atoms, then it's going to be a tetrahedral molecular shape as well. If you have one lone pair, then and the rest are atoms, it's going to be trigonal pyramidal. Okay, here we go, like a pyramid. If you've got two lone pairs and two bonded atoms, electron geometry is tetrahedral, but your molecular shape is bent. And if three things are lone pairs and one bonded atom, and there's one bonded atom, then you are going to have a linear molecular shape, but your electron geometry is still tetrahedral.